Welcome back, mathematicians. Today we're going to talk about infinite limits. So let's look at these two functions here. We have f of x equals 1 over x minus 1, and we have g of x equals 1 over x minus 1 squared. So let's find these limits. The limit as x approaches 1 from the left of f of x. So here's x equals 1. Remember, that minus sign means from the left. So we're going to start at like 0 and get closer and closer to x equals 1. If we go closer to x equals 1, it looks like we're going down, 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 all the way to negative infinity. And if we're going from the right side, remember that plus means from the right, we're going up from 2, we're getting closer to that x equals 1 line, and we're going up, 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 and it looks like it's going up forever. It's positive infinity. Now, if we have negative infinity from the left and positive infinity from the right, what's the limit as x approaches 1 of f of x? Well, since they're not the same, the limit does not exist. Let's look at g of x. So here's g of x. We want the limit as x approaches 1 from the left of g of x. So here's 1. We'll start at like 0, get closer and closer, and we're going up forever. So our limit will equal positive infinity. And this is the same as f of x. We're going up forever, positive infinity. So the limit as x approaches 1 of g of x. Well, if we look from the left and the right, are they the same? Yes. So it's equal to positive infinity. Now let's think about this. What do limits that produce results of infinity or negative infinity say about the function? What do we notice is happening on these graphs at x equals 1? We have vertical asymptotes. Here is our vertical asymptote. The function is getting closer and closer to these lines, the vertical asymptote, but it never touches. So x equals 1 is a vertical asymptote. So the definition actually of a vertical asymptote is if the limit as x approaches c, where c is some number, from the left of the function is positive or negative infinity, or from the right of the function is positive or negative infinity, then x equals c is a vertical asymptote. Now, how can we find where it's equal to positive or negative infinity? Most of the time, this happens with rational functions. Remember, rational functions are fractions. So when we want a vertical asymptote, we're going to look for where the denominator was 0. So here, x minus 1 is 0 when x is 1. Now, why does that produce a result of infinity or negative infinity? Let's think about that. Well, if we have, for example, 10 divided by 1, that's 10. 10 divided by 0.1 is 100. 10 divided by 0.001 would be 10,000. The closer we get to 0 in our denominator, the bigger our result is. And remember, limits are not actually putting 0 in the denominator. They're approaching 0. They're getting really, really close to 0, but never actually equaling 0. So when we have a number divided by a really small number, that approaches infinity. So let's determine the vertical asymptotes for these two functions. So we said we want the denominator to approach 0. So the vertical asymptote will be when our denominator is equal to 0. So we're going to set 2 parentheses x minus 1 equal to 0, and we'll solve. I did a plus 1 there. So x equals 1 is our vertical asymptote. Let's look at this function. F of x equals cotangent of x. Remember, cotangent of x is the same as cosine of x over sine of x. So again, we want our denominator to equal 0 to find our vertical asymptote. So if we look on our unit circle, which you have to memorize, we'll see the first number is always cosine, the second number is sine. So we want to find the angles where we have sine is 0. So one angle is 0. Sine of 0 is 0. There's another one here. Sine of pi equals 0. So we get x equals 0 and x equals pi. Now, in our unit circle, we can keep going. This is 0. This is pi. Every half circle, we can add pi. So pi with another pi is 2 pi. And we keep going, another pi, 3 pi, 4 pi, 5 pi, 6 pi. We can keep going and going and going. So we could write x equals 0 plus k pi, where k is some number. Let's try one more example. Let's find the limit as x approaches 2 from the left of -1 divided by x minus 2. So if we're going from the left, first we should always try to plug in our value. If we plug in 2 in our denominator, we get -1 over 0. So that's telling us that we're going to be approaching positive or negative infinity. To determine the sign, we have to plug in numbers close to 2 from the left. So what's a number close to 2 from the left? 1.9. So we'll get -1 divided by 1.9 minus 2. That's equal to -1 over -0.1. Remember, we already determined that it was positive or negative infinity. All we're doing here is determining the sign. So negative divided by a negative is a positive. So we'll say the limit as x approaches 2 from the left of -1 over x minus 2 is positive infinity. Now let's try it from the right. What's a number to the right of 2? 2.1. -2 over 2.1 minus 2. So -1 over a positive 0.1. And again, remember, all we care about is the sign. Negative divided by positive is a negative. And remember, this was approaching -1 over 0. So if we have a negative number here, this will be negative infinity. The limit as x approaches 2 from the right of our function, -1 over x minus 2, is negative infinity. So make sure that you always check your sign by plugging in numbers for when you get infinity, a number over 0 for your limit. That's all for now. Bye.